Obesity cannot be fully understood without examining the way modern food has been engineered, not simply in terms of calories or ingredients, but in how it interacts with the brain's regulatory systems. Ultra-processed foods, which dominate the diets of many industrialized societies, do more than just provide energy. They are specifically designed to stimulate appetite, delay fullness, and encourage overconsumption. These foods bypass the body's natural satiety cues in ways that whole foods simply do not, which helps explain why even people who try to monitor portions or eat in moderation often find themselves eating more than they intended. Satiety, the feeling of fullness that tells us to stop eating, is not governed by a single signal, but rather a complex interplay of hormones, neural responses, and gut-brain communication. As food enters the stomach and intestines, it stretches tissues, stimulates receptors, and triggers the release of hormones like cholecystokinin, CCK, peptide YY, PYY, and GLP-1, which tell the brain that enough food has been consumed. This system is highly responsive to the physical and chemical properties of food: volume, texture, fiber content, protein, and the rate at which food is digested all matter. Natural, whole foods, especially those high in fiber and protein, trigger strong satiety signals because they require chewing, digest slowly, and stimulate sustained hormonal feedback. Ultra-processed foods, by contrast, are engineered for ease, speed, and hyperpalatability. They often contain refined flours, added sugars, hydrogenated fats, artificial flavors, and emulsifiers that strip away fiber and protein while enhancing taste, texture, and shelf life. These products are designed to be eaten quickly and effortlessly, often with minimal chewing or digestive resistance. As a result, they enter the digestive system rapidly and are absorbed quickly, triggering sharp spikes in blood sugar and insulin but failing to adequately activate the body's natural satiety mechanisms. This mismatch between intake and satisfaction creates what researchers call hedonic hunger, a drive to eat based on pleasure, not physiological need. Moreover, ultra-processed foods activate the brain's reward system far more intensely than whole foods. The combination of sugar, fat, and salt, often in precise ratios, stimulates dopamine release in a way that resembles addictive substances. Over time, this can alter reward thresholds, making it harder to feel satisfied by simpler foods and increasing cravings for processed options. This neural hijacking of the appetite system leads to a condition in which people feel hungry again soon after eating, even if they've consumed an adequate number of calories. Worse, this type of eating can become habitual and emotionally reinforcing, creating a pattern that is difficult to break without conscious intervention. The speed of consumption also plays a critical role. Processed foods are often soft, smooth, and hyperpalatable, allowing for rapid eating that doesn't give the body enough time to register fullness. Satiety signals take 15 to 20 minutes to reach the brain, but ultra-processed meals can be consumed entirely in a fraction of that time. This encourages passive overeating, not out of greed, but because the feedback loop between the gut and the brain is disrupted by design. Foods like potato chips, sugary cereals, or soft pastries are consumed rapidly and in large volumes before the body can effectively intervene. Another layer to this problem is that ultra-processed foods are typically low in water content and fiber, meaning they are highly calorie-dense per bite. This reduces the stomach's stretch response and limits the gut's ability to generate the mechanical and hormonal triggers of satiety. A small amount of processed snack food can contain hundreds of calories without creating the physical fullness that would be experienced from eating a fiber-rich salad, legumes, or whole grains. In this way, these foods bypass the body's built-in calorie counting system, leading to chronic overeating despite efforts to practice restraint. This is not merely a theoretical concern. It's been demonstrated in controlled experiments. In one landmark study, participants were fed either ultra-processed or unprocessed diets that were carefully matched for calories, sugar, fat, fiber, and protein. Despite these similarities on paper, those eating the ultra-processed diet consumed, on average, over 500 more calories per day, gained weight, and had increased hunger hormones. The unprocessed group, by contrast, lost weight and felt fuller, even though they had free access to food. The conclusion is striking. The physical form and processing of food profoundly alter how the body perceives and responds to it. This understanding shifts the conversation around obesity away from personal failure or simple calorie math and toward a more accurate model that recognizes how industrial food systems have outpaced our biology. Most people are not choosing to overeat. They are consuming products that are deliberately designed to override the body's normal regulatory systems. Even people with strong knowledge of nutrition may find themselves struggling with satiety if most of their diet comes from ultra-processed sources. The solution is not to demonize individuals or enforce rigid dietary rules, but to increase awareness about how these foods work, and to support environments where whole, minimally processed foods are more accessible, affordable, and culturally normalized. Building meals around foods that require chewing, contain fiber, and digest slowly, such as vegetables, whole grains, legumes, nuts, and lean proteins, can help restore satiety signals and reduce unconscious overeating. Relearning to eat more slowly, to pause between bites, and to eat without distraction can also help reconnect the mind and body in ways that processed foods tend to sever. Ultimately, understanding the engineered nature of ultra-processed foods reminds us that the challenge of obesity is not merely about willpower, but about the environment we live in, an environment shaped by industries whose goals often conflict with our biological well-being. Restoring our ability to feel full, to stop when we've had enough, and to enjoy food without being manipulated by it is not just a nutritional strategy. It is a necessary act of reclaiming physiological autonomy in a food landscape that too often works against it.